Morning everyone. So today we are going to talk about applied thermodynamics and especially about steam turbines. So firstly let's understand what are the topics that we are going to cover today. Firstly we will understand the combined velocity diagram. Then we will learn how to calculate the tangential force and the power which is getting produced because of steam turbine. Then we will understand the various types of efficiencies, and finally we will calculate what is the condition for maximum efficiency of steam turbine. Now let's understand the combined velocity diagram. Now whenever I say combined velocity diagram, the name itself indicates it is the combination of inlet velocity triangle and the outlet velocity triangle, right? Now from this figure, B is my starting point, right? So from this particular point, the steam is coming out of the nozzle at some velocities. So here V1 is indicating the velocity of the steam at inlet. This steam is coming at an angle of alpha. Okay, now we can see over here, whenever I talk about triangle BED, this triangle is right angle triangle. Okay, and this BD is my horizontal component, DE is my vertical component, where V1 is my hypotenuse, right? So this BD can be given by what? We can call it as V1 cos alpha, because BD is my adjacent component, adjacent side. So this BD is nothing but V1 cos alpha, or I have represented this as VW1. This DE is my vertical component, which is exactly opposite to this angle alpha. So we can call DE as V1 sin alpha, or I have mentioned it as VF1. Now what is this VW1? This VW1 is indicating the whirl velocity at inlet. Because of this particular velocity, the system is having whirl within itself, right? After the application of force. Okay, so VW1 is the velocity, which is called as velocity of whirl. Okay, VF1 is my velocity of flow. Okay, so this is the velocity of the steam which is getting flown over the rotor surface. So that's why it is called as velocity of flow. VR1 is my relative velocity. Okay, and it is having an angle of theta, which is nothing but blade angle at inlet, right? Now when the steam strikes the nozzle, steam strikes the blade, okay, the blade will certainly move with the velocity of u, which is called as blade velocity, right? Now V1, VR1 and VF1, these are the inlet velocities, and exactly opposite to it we have the velocities like VF2, V2, VR2, which are indicating the velocities at outlet, right? Now as like alpha in the inlet system, okay, we have beta in the outlet system. So beta is nothing but my nozzle angle at outlet. As like theta, we have phi in the outlet system, which is nothing but blade angle at outlet, right? Now here you can see in this particular triangle, BC is my common section for both the triangles. So here we can clearly see the velocity of blade at inlet and outlet, okay, will be same, which is nothing but u. Okay, so this whole diagram is called as the combined velocity diagram for steam turbines. I have given the terminology for the each and every session. Okay, so I hope you have understood the combined velocity diagram. Thank you.